We live in a digital age, a world awash in data. Every click, every like, every search we make leaves a digital footprint. But what if I told you these footprints weren't just being tracked, but harvested? This isn't about cookies or targeted ads. This is about something far bigger. This is about the silent theft of human intelligence itself. Tech giants, once scrappy startups, became behemoths, their algorithms reaching into every corner of our lives. Our data, the very essence of our experiences, thoughts, and desires, transformed into the currency of a new world order. This isn't science fiction. It's happening right now. Every time you unlock your phone, every time you scroll through your feed, you're feeding the beast. But this isn't just about privacy. It's about something far more fundamental. It's about the very nature of intelligence, of creativity, of what it means to be human. AI isn't just learning from our data, it's mimicking us. It's learning to write like us, to paint like us, to think like us. This is the story of how AI is stealing our data, and in doing so, stealing our future. Leading this charge was a British mathematician named Alan Turing, a man whose genius would forever alter the course of history. His now famous Turing test, designed to assess a machine's ability to exhibit intelligent behavior indistinguishable from a human's, became a benchmark in the nascent field of artificial intelligence. John McCarthy, Marvin Minsky, Claude Shannon, and Nathaniel Rochester organized a summer research project that would formally christen this burgeoning area of study artificial intelligence. The Dartmouth Conference was a watershed moment. The goal was ambitious: to create machines capable of not just mimicking human thought, but of surpassing it. Early AI research focused on symbolic reasoning, attempting to codify human knowledge into a set of rules that machines could then manipulate. These early AI programs, often referred to as expert systems, showed promise in specific domains. But their limitations quickly became apparent. These early AI systems were brittle, unable to adapt to new situations or learn from their mistakes. They lacked the flexibility and adaptability of the human mind, the ability to navigate the messy, unpredictable real world. And by the 1970s, a new realization began to dawn on AI researchers. To truly replicate human intelligence, machines needed more than just rules. They needed experience. They needed to interact with the world, to learn from their successes and failures, just as humans do. This realization led to a shift in focus from symbolic reasoning to knowledge representation and reasoning. Rodney Brooks at MIT championed a bottom-up approach, building robots like Cog that learned through trial and error, their actions shaped by sensory input and feedback from the real world. In 1997, Deep Blue made history by defeating chess grandmaster Garry Kasparov, marking a significant milestone in the evolution of artificial intelligence. As AI research progressed, a fundamental challenge emerged: how to equip machines with the vast and intricate knowledge base that humans possess. Early expert systems, while impressive in their specific domains, were essentially brittle constructs, their knowledge painstakingly hand-coded by human programmers. These early expert systems highlighted a critical bottleneck in AI development: the acquisition and representation of knowledge. It became clear that manually encoding the world's complexities into a set of rules was an insurmountable task. AI needed a new approach, one that could scale to the vastness and dynamism of human knowledge. In the 1980s, a new paradigm emerged that promised to overcome the limitations of rule-based AI connectionism. Inspired by the structure of the human brain, connectionism proposed that intelligence arose not from the manipulation of symbols, but from the intricate interplay of interconnected nodes. This idea gave rise to artificial neural networks, computational systems modeled after the biological neural networks found in the brain. Unlike their rule-bound predecessors, Neural networks learned from data, their connections strengthening or weakening based on the patterns they encountered. However, early neural networks faced their own set of challenges. They required vast amounts of data and computational power, resources that were scarce in the early days of computing. The late 1990s and early 2000s witnessed a confluence of factors that breathed new life into the field of AI. The exponential growth of computing power, coupled with the rise of the internet and the explosion of digital data, created fertile ground for the resurgence of neural networks. This time, however, neural networks were armed with a powerful new weapon: deep learning. Deep learning algorithms, characterized by their use of multiple layers of interconnected nodes, proved capable of extracting complex patterns from massive data sets, surpassing human performance in tasks like image recognition and natural language processing. The question was no longer whether machines could think, but what would happen when they surpassed human intelligence in every aspect. The early 21st century saw a seismic shift in the landscape of AI. At the heart of this revolution lay a powerful new approach: deep learning. Unlike their predecessors, which relied on handcrafted rules and limited datasets, deep learning algorithms possessed an uncanny ability to learn from vast amounts of data. These algorithms, structured as complex networks of interconnected nodes, could discern intricate patterns and make predictions with an accuracy that astonished even the most seasoned AI researchers. Every click, every like, every search query generated a digital breadcrumb, collectively forming a vast and ever-growing digital ocean that AI researchers could tap into. In 2014, Google acquired a small British AI startup called DeepMind for a reported $500 million. DeepMind's claim to fame: a deep learning algorithm capable of mastering Atari video games at superhuman levels. This algorithm, dubbed DQN, learned to play classic games like Breakout, Space Invaders, and Pac-Man by trial and error, receiving only the raw pixel data from the game screen as input. Remarkably, DQN not only learned to play these games, but in many cases surpassed the skills of even the most seasoned human players. This breakthrough opened up a world of possibilities, from self-driving cars to personalized medicine, where AI could learn and adapt to complex, ever-changing situations. To understand the significance of DeepMind's Go-playing AI, one must first appreciate the game itself. Go, with its simple rules yet profound strategic depth, had long been considered the holy grail of AI research. DeepMind's answer to this challenge was AlphaGo, a deep learning algorithm specifically designed to tackle the complexities of Go. AlphaGo combined the power of two neural networks working in tandem: a policy network which selected the next move, and a value network which evaluated the position of the board. In 2016, AlphaGo faced its ultimate test. A 5-game match against Lee Sedol, one of the world's top Go players. AlphaGo emerged victorious, winning 4 out of the 5 games. The rise of deep learning marked a turning point in the evolution of AI. But this revolution wasn't built on algorithms alone. It was fueled by something far more fundamental: data. Just as the human brain learns and adapts through experience, so too do deep learning algorithms rely on vast quantities of data to train their artificial neural networks. These networks, with their intricate webs of interconnected nodes, act like digital sponges, soaking up information and identifying patterns that would be impossible for even the most astute human observer to detect. This insatiable hunger for data, this constant need for more information to refine its models and improve its accuracy, lies at the heart of AI's complex relationship with humanity. Section 2. The digital gold rush: from surveillance to exploitation. The quest for data isn't new. Governments and corporations have long recognized the value of information, using it to track trends, predict behavior, and exert control. But the rise of the internet, coupled with the ubiquity of smartphones and the explosion of social media, created a data gold rush of unprecedented scale. Suddenly, every aspect of our lives, from our online purchases to our social interactions to our physical movements, was being tracked, analyzed, and monetized. The internet, once hailed as a tool for democratization and free expression, became a vast surveillance apparatus, with tech giants like Google, Facebook, and Amazon amassing unprecedented troves of personal data.
But unlike traditional forms of surveillance, which often relied on brute force and overt observation, this new digital panopticon operated with a seductive subtlety. We willingly surrendered our data in exchange for convenience, entertainment, and the illusion of connection. Every like, every share, every click became a data point, feeding the algorithms that shaped our online experiences and increasingly our offline lives as well. This data-driven ecosystem, while undoubtedly profitable for the tech giants that control it, has come at a steep cost. Our privacy has been eroded, our autonomy undermined, and our very identities commodified. The question is, have we traded away too much in our pursuit of a digitally enhanced existence?
Section 3. The shadow workforce fueling the AI machine. While the data we generate through our online activities undoubtedly plays a crucial role in training AI systems, it's not the whole story.
Behind the sleek interfaces and seemingly intelligent algorithms lies a hidden human cost. A shadow workforce toiling away in the digital shadows, annotating data, training AI models, and ensuring the smooth functioning of the artificial intelligence machine.
This hidden labor force, often located in developing countries and paid a pittance for their efforts, performs tasks that are essential for AI development but too tedious or nuanced for machines to handle on their own. They label images, transcribe audio, moderate content, and perform countless other tasks that require human judgment and intuition.
These ghost workers, as they're sometimes called, are the unsung heroes of the AI revolution, their labor often invisible to the end users who benefit from their efforts.
Yet their work raises uncomfortable questions about exploitation, inequality, and the true cost of AI progress. How ethical is it to build AI systems on the backs of low-wage workers, often operating in precarious conditions with little job security or benefits?
And what happens when these workers are replaced by the very technologies they helped create?
These are just some of the ethical dilemmas that we must grapple with as we navigate the complex landscape of AI in the 21st century. The automation paradox, job displacement, and the rise of new skills. The rapid advancement of AI has sparked anxiety about its impact on jobs. The fear is that intelligent machines will render humans obsolete, leading to mass unemployment. AI will automate many tasks currently performed by humans. Repetitive jobs in manufacturing, transportation, and customer service are being displaced by robots. Technological innovation, while disruptive, tends to create more jobs than it destroys. The Industrial Revolution, for example, led to new industries and jobs. As machines take over routine tasks, humans will focus on creativity and problem solving. The challenge is to invest in education and training for an AI-driven economy.
Beyond the immediate concerns about jobs and economic security, the rise of AI raises profound existential questions.
As machines become increasingly intelligent, what does it mean to be human? Some envision a dystopian future where superintelligent machines turn on humanity.
Others see a future of human-machine symbiosis, enhancing our abilities and solving challenges.
This vision suggests we're on the cusp of a new era, blurring the boundaries between human and machine. First and foremost, we need to address the issue of bias in AI. The future of AI is not predetermined. It will be shaped by the choices we make today.
To ensure AI benefits all of humanity, we must address ethical, social, and economic challenges.
Algorithms are only as good as the data they're trained on. If that data reflects biases, AI systems will amplify those biases.
This can lead to discrimination in hiring, lending, and criminal justice.
We need mechanisms for auditing AI systems for bias and holding developers accountable for their creations. We stand at a crossroads, a pivotal moment in human history. The rise of artificial intelligence has become an undeniable reality, reaching into every aspect of our lives. From curating our news feeds to answering our questions, AI is now integral to our daily existence. This rapid proliferation of intelligent machines presents profound challenges and forces us to confront uncomfortable truths. The choices we make today will determine the course of our shared future. The future of AI is not predetermined. We have the power to shape it, where humans and machines can coexist and thrive. AI is a tool reflecting our values and aspirations. We must resist technological determinism. AI is a product of human ingenuity. Prioritize human values in AI design and deployment. Ensure AI systems are fair, unbiased, and transparent. The AI revolution is upon us, and we must lead it. Let's shape a future where technology empowers humanity.